So in your entire mathematical career, when you represented graphs, you represented them as collections of points x, comma, y on the rectangular coordinate system. That grid that you know and love from when you first learned it in middle school, probably. But the corresponding equations for these graphs have always been in either rectangular coordinates, which is the most common way, or the newly learned parametric form. But in this section, we're going to study the polar coordinate system. It was first introduced by James Bernoulli in 1691. That's right, this dates back to over 300 and some years ago. And it's a very interesting system and has a great many uses. Now, the polar coordinate system are defining the entire coordinate system from the pole or the origin, which is a point O. And then you construct from O an initial ray called the polar axis. So that's this ray right here. So that's the polar axis. You have your origin, O, right there. And then you take a point P, which is out here. That point P is defined, right, so right there, there's the point P. But you define it from r comma theta, where r is the length of this distance, right? It's the distance from the origin out to the point P, and it's directed distance. That's r. And theta, the angle that you're building, if I could write the letter theta, there we go, is the directed angle. It's assumed to be counterclockwise from the polar axis out to that point or that ray, or it's that segment OP, right? So this is fascinating, right? You can still get to that point P, but instead of saying, oh, I go over X up Y, you say, all right, tell me how far out it is, and then tell me what angle it forms with the polar axis, which you've known as the positive x-axis. Now, if this is sounding familiar, that's because you've used this when you've built the unit circle back in pre-calc, right? So just like we have a grid for rectangular coordinates, there's a grid for polar coordinates, and it looks like this. This is built in Desmos, but there are plenty of others. So it has concentric circles, which are different radiuses, different distances, different r's, right? So that r is 1, r is 2, r is 3, r is 4, r is 5. So these are r values, right? How far out from the pole. This circle is 5 out from that pole. This big circle out here is 10 out from that pole. That's what makes a circle, is that the distance is always the same, right? So you'd say out however many, and then you pick an angle. So for example, if I want to get to this point over here, well, I can tell you right now that the r value is 9 because I'm on the 9th ring. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. That's my r value. And then what's my theta value? What's the angle? Well, the angle, let's think about this. I want to go back to the pole right there. Okay, so that value right there is 9. And then the angle is the angle that I would form from the positive polar axis right here over to that line segment OP, right? Here's the origin, here's point P. So from the origin to point P is an angle of 2 pi over 3. So that's my theta. Amazing, isn't it? It'll get you to the same points as the XY coordinate system, but it gets you there in a completely different way, right? You think about it a different way. In this system, it's frequently convenient to locate points with respect to a grid of concentric circles, like I was doing, right? So I knew this was 9 for the r value because I'm on the 9th circle. And then you intersect them with radial lines that give you some hints as to some of the angles. And you can see those same radial lines are the ones that you memorized when you memorized the unit circle in pre-calc. At least some of them are. Now we can expand on this a little bit to go a couple ways. So an initial radius can actually be positive or negative. I'll show you what that looks like in a second. And that angle theta is assumed to be a directed angle. It's counterclockwise from the initial radius, the initial polar axis. So on the previous page, I called this the polar axis, right? It's the positive x-axis that you know and love. So positive angles mean that you're moving counterclockwise, just like it says. But negative angles would mean you're moving clockwise. And that's why you learn them that way when you learn the unit circle, right? So if you think about the positive polar axis is right here. Hello, positive polar axis right here. This is positive pi over 6. This is 11 pi over 6, but also negative pi over 6, right? So, I mean, we don't write that way all the time because, well, of course, we also learn that there's infinitely many of these. So pi over 6, but then I could go around and end up there again, which would make it 13 pi over 6. And I could go around again, etc. Right? All right, so positive angles counterclockwise, negative angles clockwise. So we're going to find for our theta pairings given the point below. So there's a point right here. See a point P right here? So we have to think about how we could get to that point in the polar coordinate system. Okay, so a couple of things. When I think about how I'm out 1 ring, 2 rings, 3 rings, 4 rings. So that's 4 because I can tell because this darker ring right here is 5. It's got a little 5 down here. So that's the 4th ring. So I know I can say that it is 4 for my R. So remember how these work. It goes R, comma, theta. So 4 is my R. I'm on the 4th ring to get out here. Right? Comma. And then I have to think about my angle. What angle gets me here? Well, it's 7 pi over 6. I can see that. So 7 pi over 6. Wonderful. So out to the 4th ring, zoom around 7 pi over 6, and there you go. All right, but it wants 4 pairings. It doesn't just want 1. It wants 4 of them. 2 of them with positive angles, you'll notice. And 2 of them with negative angles. Oop. All right, well, let's find another way to get here. So let's say we're going to go out 4. Oop, sorry, negative angle, positive angle. So let's say we're going to go out to the 4th ring. So 1, 2, 3, 4. Instead of going counterclockwise, I could go clockwise. I could go this way. And that would be a negative 5 pi over 6, right? So this was 7 pi over 6 right here. So that would work, right? Because I would go out 4. So 1, 2, 3, 4, and then swing around negative 5 pi over 6, and that would get me there. You'll notice 5 and 7 together make 12, and 12 pi over 6 is 2 pi, because the 2 of them together are covering that full circle, if you want to think of it that way. All right, so I've come up with the 2 that have positive r's. I'm not going to be able to do it with negative r, or I'm not going to be able to do 2 more like this because I'm restricted to being between 0 and 2 pi and negative 2 pi and 0. If that restriction wasn't there, I could just keep adding on. I could go around and around and do loop-de-loops, right? But they said they only want it to be between 0 and 2 pi and negative 2 pi and 0. All right, so let's get to this angle another way. How about we go negative r? So let me go negative 4. So if you think of how I've been doing this, when I said, oh, it's 4 for negative 5 pi over 6, I said go out 1, 2, 3, 4 on this positive polar axis and loop around and get to negative 5 pi over 6, and that gets you out to this point. But if I start at negative 4, that actually starts me on the negative polar axis. So instead of the positive one, which is pink over here, I'd go 1, 2, 3, 4. It would get me here, and then I would just have to loop down into this angle. Well, that's only a negative pi over 6. So I go negative 4 down that bit. Oh, no, it's positive. Whoops, it's not negative. It's counterclockwise. Sorry, lost it. You're going counterclockwise. Counterclockwise is positive. All right. Then what if I went to that same point and I went around, right? If I go around to get me there, that's negative because I'm going clockwise. So that would be -4 because I start out here at the -4, right? Not the positive polar axis, but it's opposite. And then I loop all the way around. So that's -11 pi over 6 radians that I moved. So now we kind of see what I meant up here. When you have a positive radius, it means that your initial ray is the positive polar axis. What you and I know of as the x-axis, right? The positive x-axis right here, right? So it's the positive polar axis. When you have a negative value as your start, it means that your initial ray is actually, well, the negative polar axis. The negative x-axis. So in rectangular coordinate systems, this is the positive x-axis. And this is the negative x-axis. That's what we mean when we say we could have a positive R or a negative R. And then we also see what it means to have counterclockwise, as long as you remember it. Counterclockwise is going this way around, and clockwise is going this way